Good morning, ladies and gentlemen, and happy Monday. Today is March 23rd, 2020. We're doing lesson 14, coordinate proofs. There's a lot to unpack here, so let's jump right in. So this lesson is about proving geometric theorems using algebraic techniques, which is really the whole point of this unit. We want to be able to prove geometric theorems using algebra. 14.1, which one doesn't belong? Well, we can't really do this question here. But you can see we're going to be looking at quadrilaterals today as we explore these geometric theorems. In 14.2, name this quadrilateral. We're given the vertices of a quadrilateral. We're asked, what type of quadrilateral is it? Well, we don't really know what type of quadrilateral it is yet. It could be a parallelogram, it could be a rectangle, a rhombus, a square, or a trapezoid. But we can't really figure this out unless we use some algebraic techniques. So let's take a look at what it looks like on a graph. Here we can see the plots pointed, and we can already tell kind of what it looks like. Let's connect the dots using some magic. There we go. And now we can definitely tell this looks like a rectangle. But this looks like a rectangle is not exactly a geometric proof. We need some evidence. So we're going to start by finding the slope of each one of these lines. Starting on the bottom left, we can see that it goes down 12 and to the right 9, making the slope a negative 4/3. If we do the same thing with the line opposite, we can see that it has the same exact slope. Great. Now let's find the slope of the short end at the top. We can see that it goes up 3 and to the right 4, making this slope 3/4. We do the same thing with the opposite side and see that it has the same slope. So since opposite sides have the same slope, that means that this quadrilateral must be a parallelogram. But we don't stop there. We want to be as specific as we can as to what type of quadrilateral this is. We can also tell that the slopes are opposite reciprocals to each other, which means that the lines that are next to each other form right angles. They're perpendicular to each other. Since we have 4 right angles, then we know that this shape is also a rectangle. The proof does not end there. We actually still need to show that this figure is not a square. So if you take a look at the sides that are next to each other, we can clearly see that they're not the same length. We can say that this is not a square, which means that our figure must be a rectangle. Question number 2. Find the perimeter of this quadrilateral. Well, since we already did all of the work in finding the change in y over change in x for all of these sides, it actually becomes a lot easier now to just find the length of each one of these sides. We could simply use the Pythagorean theorem to find that the short sides would have to be a length of 5, and the longer sides would have to be a length of 15. So to find the perimeter, we simply just add all the sides together and get a perimeter of 40. Question 3 asks us to find the area of the quadrilateral. Well, since it's a rectangle, no problem. Take the area, multiply the length times the width, we get 75. 14.3, circular logic. Here we're going to use algebraic techniques to prove a geometric property that we haven't seen before. We start off with a circle. First question, they talk about the points BC. What is that to the circle? Well, we know, since it goes from one end to the other and goes through the center, that is the diameter of the circle. It then asks us to pick a point that's on the circle. It gives us a few choices. I decided to pick point 3, 4, and we call that point D. Then we're going to draw lines in from BD and DC, so it forms an angle. The question is, what do we think is true about that angle? We might already have some guesses, but we need algebraic proof to see what is really happening here. So we're going to find the slopes of these two lines. We find the slope of BD actually goes up 4 and to the right 8, which means we have a slope of 1/2. And for DC, it actually goes down 4 and to the right 2, which means we have a slope of -2. So as we can see, the slopes are opposite reciprocals of each other, which means that angle D has to be a right angle. Now next, we're supposed to compare our results. So do that. I'm going to trust that you guys are comparing your results right now. So you're watching this video. We also have a digital part to this activity, and I was playing around with that earlier. This is what that looked like. Ooh. Ah. Oh, we can look at the slopes. Ooh. Look at that. How cool. So hopefully you can see that no matter where we put point D, it's always going to be a right angle. And this is actually a geometric property that we are going to want to know for next unit especially. If an angle is made where the vertex is on the circle and the endpoints are on the diameter, the angle must be a right angle. Cool. So like I said at the beginning of this video, this really wraps up the main part of this unit in that we can use algebraic techniques to prove things about geometric figures. I want you to take a moment and remember back in Unit 2, where we had to do proofs using the two columns or paragraph proofs to prove things like in a rectangle, the diagonals have to be congruent. Well, just think about doing that type of problem, but put that rectangle on a grid and now prove that the lengths are congruent. Well, we can do that using the distance formula or Pythagorean theorem to find the lengths of the sides. We can prove that we have a rectangle by showing that the lines opposite each other are parallel and the lines next to each other are perpendicular. So it really allows us to take those same exact proofs that we did before and prove them in a new way. Sometimes it's a lot easier than what we did before, and sometimes it's not. It really depends on the question that we're being asked. But now you have a new look into how we can do geometric proofs. So that's our lesson for today, but I still have one question left for you. I need a catchphrase for the end of these videos, and I want to know, what do you think my catchphrase should be? Please leave a comment below letting me know what you think I should say, and maybe I'll use it in my next video. But until then, I don't really know how to end this. So, yeah. Bye!